Hello friends, welcome to my YouTube channel Physics Learning with Runi Sharma. Today I am going to discuss about quantum mechanics topic, special cases of Planck's radiation law. So actually there are two special cases of Planck's radiation law. The first case is Planck's formula for lower frequency and another one is Planck's formula for higher frequency. I have already discussed first case, which is Planck's formula for lower frequency. So if you have not gone through that video, then please go and first watch it. I will provide my previous video link in my description box. So today I will discuss about Planck's formula for higher frequency. So we know, according to Planck's radiation law, we get two expressions. They are E lambda d lambda is equal to 8 pi hc divided by lambda to the power 5 into d lambda divided by e to the power hc by lambda kt minus 1, and E nu d nu is equal to 8 pi h nu cube divided by c cube into d nu divided by e to the power h nu by kt minus 1. So this expression is expressed in terms of wavelength and this expression is expressed in terms of frequency. And I have already discussed about these two expressions. Also I will provide my both previous video link in my description box. So now for higher frequency, it has lower wavelength. For higher frequency, it has lower wavelength. Then, as I have said that it has lower wavelength, so lambda will be very small. So if lambda is very small, then the quantity e to the power ac by lambda kt will be very large as compared to 1. On the other hand, e to the power h nu by kt will also be very large as compared to 1. Therefore, we can write e to the power hc by lambda kt is very larger than 1, or e to the power h nu by kt is also very large than 1. So we can neglect 1. As it is very small. Now the expression becomes means both the expression 1 and 2 become. So E lambda d lambda is equal to 8 pi hc divided by lambda to the power 5 into d lambda divided by e to the power ac by lambda kt. We can neglect 1 as it is very small. So we can write 8 pi hc lambda to the power 5 into e to the power minus hc by lambda kt d lambda. E lambda d lambda is equal to. This is expressed in terms of wavelength, and this is called as Wien's law. Also, this expression is called as Wien's law expression. Also, if we want to express in terms of frequency, then the expression become E nu d nu is equal to 8 pi h nu cube divided by c cube into e to the power minus h nu by kt d nu. This is expressed in terms of frequency. Neglecting 1. So we can conclude that from both the cases that these are the two special cases of Planck's radiation law, as I have already said, and we have seen that Rayleigh-Jeans law is valid for higher frequency and Wien's law is valid for lower we have seen that Rayleigh-Jeans law is valid for higher wavelength, and Wien's law is valid for shorter wavelength. So, if you have any doubt regarding both the cases, you can comment me below, and if you like my video, then please share and subscribe. Thank you for watching.